Welcome to the DIY Honda Garage channel. Welcome to our troubleshooting guide for the DTC P0340, which indicates a CMP sensor A no signal issue in the Honda Civic models from 2006 to 2011. This diagnostic trouble code, DTC, primarily refers to a malfunction involving the camshaft position CMP sensor A. The CMP sensor A plays a crucial role in monitoring the position of the camshaft to ensure proper timing for fuel injection and ignition. This code may impact engine performance and efficiency. We will explore detailed troubleshooting procedures, highlighting potential problems and their resolutions. Let's get started on diagnosing this issue effectively. The DTC P0340 identifies an issue with the camshaft position CMP sensor A, which is integral for ensuring the engine operates efficiently. This sensor detects the position of the camshaft and relays this information to the Engine Control Module, ECM. The ECM uses these signals to control the timing of fuel injection and ignition, which are essential for optimal engine performance. The CMP sensor A is generally located adjacent to the camshaft within the engine assembly, making its accessibility critical for troubleshooting. If there is a failure in the signal from this sensor, it can lead to various performance issues, such as rough idling, decreased fuel efficiency, or even engine stalling. Understanding the role and position of the CMP sensor A is crucial for effective diagnostics and repairs. Several potential causes can lead to the DTC P0340 being triggered. An open circuit in the wiring from the CMP sensor A to the ECM can result in a lost signal. This can occur due to wear and tear or damage to the wiring harness. Another possible cause is a faulty CMP sensor itself. If the sensor malfunctions, it won't send the necessary signals to the ECM. Additionally, the ECM could potentially be defective, which would impede its ability to read signals from the sensor. Poor connections or loose terminals can also create intermittent failures, making it crucial to inspect these components thoroughly as part of the diagnostic process. Understanding these causes helps narrow down troubleshooting efforts efficiently. When the P0340 code occurs, several symptoms may manifest in the vehicle's operation. Drivers might experience engine stalling or rough idling, indicating an inconsistency in engine performance. Additionally, there could be a noticeable drop in fuel efficiency due to improper timing caused by a failed CMP sensor. Users might also face difficulty starting the engine as the ECM struggles to obtain the necessary camshaft position data for ignition. Typically, the check engine light will illuminate, serving as a warning signal for the driver. In some cases, the vehicle might experience an unexpected loss of power during acceleration, indicating a significant performance issue resulting from the sensor's malfunction. Recognizing these symptoms early can save time and resources in diagnosing the underlying problem. The first troubleshooting step involves turning the ignition switch to the on position, labeled as 2. It's essential to ensure all electrical systems are powered for accurate diagnostics. Before proceeding, record any freeze data and onboard snapshots, as this information is vital for understanding past events leading to the DTC. Additionally, reviewing the general troubleshooting information provided in your vehicle's manual is recommended, as it may contain helpful insights tailored to the P0340 error code. This step sets the stage for an effective diagnostic process, allowing technicians to gather comprehensive data before attempting further interventions. After recording the necessary data, the second step is to clear the DTC using the Honda Diagnostic System, HDS. This tool allows you to reset the codes and provides a fresh start for the diagnostics. Once the DTC is cleared, restart the engine and check for any pending or confirmed DTCs again with the HDS. If DTC P0340 appears, this reinforces the existence of an ongoing issue with the CMP sensor A signal. If it doesn't reappear, it may indicate an intermittent failure, and the system might be functioning normally at that time. This step is crucial in identifying persistent issues versus temporary glitches. Next, turn the ignition switch to the lock 0 position to ensure all electrical systems are powered down securely. Once off, disconnect the CMP sensor A 3P connector. This is a critical step as it isolates the sensor from the rest of the system, allowing for individual testing. The 3P connector consists of 3 terminals and must be handled carefully to avoid any damage. Disconnecting the sensor will enable us to check the voltage levels, which will provide insights into whether the sensor is malfunctioning or if the issue lies elsewhere in the wiring or the ECM. Ensuring a safe working environment is always a priority during these diagnostic procedures. The 4th step involves turning the ignition switch back to the on-to position. Subsequently, measure the voltage at the CMP sensor A3P connector terminal number 3. Use a multimeter to check the voltage between terminal number 3 and the body ground. This terminal is responsible for receiving power from the ignition system. It's crucial to determine whether there is battery voltage present at this point. If you find battery voltage, this is a positive indicator that the wiring is intact towards the sensor. However, if there is no voltage detected, it suggests an open circuit exists between the CMP sensor A and the 10 amp fuse linked to the alternator, which signifies a need for further inspection and repair. Understanding the voltages at this terminal can direct the next steps in troubleshooting effectively. Continuing with our diagnostic process, the 5th step requires measuring the voltage at the CMP sensor A3P connector, terminal number 1. This terminal should output approximately 5 volts, which is necessary for the sensor to transmit accurate position data to the ECM. Again, use a multimeter for precision in your measurements. Check the voltage between this terminal and the body ground. If you confirm that about 5 volts is present, it indicates that the sensor is getting the appropriate power supply and may be functional. However, if there is no voltage, it suggests a potential fault either within the CMP sensor A or in the wiring leading to the ECM. Accurately measuring this voltage will significantly influence your next steps in the troubleshooting process. After completing repairs or replacements based on the prior troubleshooting steps, it's essential to perform a final verification of the repairs made. Utilize the Honda Diagnostic System, HDS, to verify that all repairs are successful. Check for the presence of any outstanding DTCs, especially the P0340 code. It is particularly important that no DTCs reoccur, which would suggest that the problem has been effectively addressed. If the DTC is not shown, the repair can be deemed successful and the vehicle can be considered ready for normal operation. This step ensures that all issues have been resolved and helps maintain the vehicle's overall reliability. Preventive maintenance is crucial in avoiding future occurrences of DTC P0340 and ensuring the longevity of your Honda Civics engine performance. Regularly inspect the wiring connected to the CMP sensor A. Look for any signs of wear and tear, as undetected damage can lead to signal issues down the line. Additionally, maintaining clean connectors can significantly improve connectivity and prevent potential intermittent failures. Using high-quality replacement parts when repairs are needed also ensures durability and proper functioning. Establishing a consistent maintenance schedule will help catch issues early before they escalate into larger problems, ultimately enhancing both vehicle reliability and performance. In conclusion, addressing the DTC P0340 involves understanding its symptoms, exploring possible causes, and diligently following the prescribed troubleshooting steps. The CMP sensor A is vital for engine performance, and any issues with this component can manifest as noticeable difficulties in vehicle operation. By systematically diagnosing and verifying repairs using tools like the Honda Diagnostic System, HDS, you can ensure that your Honda Civic operates efficiently. Lastly, implementing regular maintenance practices can prevent future occurrences of this and other DTCs, keeping your vehicle in optimal condition. Thank you for reviewing this guide, and we hope it aids you in effective automotive repair. Please like and subscribe to the channel. See you next time!